You're also talkative out there today. I like to see that. Um, all right, so while we get started here, um, so this is the new CS topics course. We're likely going to rename this the theory of programming languages because that's what it basically is coming to be here. We'll talk about that a little bit. Um, I think all of you have already had a course from me, so you're familiar with some of this stuff. We'll talk today about how I run courses, especially the online students. Some of you may not have had a course from me. A lot of it will be similar to how I run courses. There'll be some differences. Here we'll talk about how this one is a little different than some of my other courses. Actually, I think every course I teach is a little different, although I think they're like, oops, our gnome dropped. Thank you. Don't want to lose our gnome. Yeah. So, of course, we'll be using Brightspace for nearly everything here. This is a high flex course, right? So, we'll have a bunch of you in class, and we'll have like Thursdays, we'll have kind of often we'll do group assignments in class here. We'll also be recording this, like I'm recording this and zooming this right now. So if you are sick or can't come to class, you can jump on the Zoom session. Again, I always use the same Zoom session, so it's posted in the syllabus and in my contact information and stuff like that. So you can always jump on Zoom for this. And I also record the Zoom session and post it online. There will be an asynchronous option for students who are doing this asynchronously. Generally, those are online students here, but I know a couple ones like Max, it sounds like you're going to be doing this online or asynchronously a fair amount because of your work schedule. So that's okay also here. And again, that's pretty typical stuff. Um, I'm going to jump into Unit 1 and talk about this, go to this introduction to the course and just kind of go over some basics there. And then we'll jump to the syllabus today here. So what is this topics course anyway? And what topics are we actually going to cover? So this is part of the new computer science curriculum. And in a typical computer science curriculum, there are two courses that are usually taught. And one is often called a programming languages course, where you kind of take a step back after you've learned a couple programming languages, a step back and look at programming languages in general. You often compare 3 or 4 different programming languages and try to answer all those questions about programming languages, things we told you. Oh, we'll tell you about that later. Like, remember when in Java 1 where we said, oh, your methods have to always start with static main, or you have to use a static word. And a couple times we've talked, we may have mentioned static, but I don't know if we ever really looked at the theory. Do you know it from a memory point of view when you say static, what that implies and then pushes things not on the stack, but on what does that mean, stack? So again, we'll try to answer some of those questions. Why are there integer? What's the difference between a primitive type and an object type and passing them as parameter? And again, not just kind of understand, but looking at it from a number of different languages and how this works. So that's a programming languages course. We'll also look at some programming languages that you're probably not familiar with, particularly functional languages and where they're used for this. Now, at some universities, this course might deal more with functional languages. It's typical that a faculty person who really loves some abstract or weird language will take this course kind of over and teach it largely on some weird functional language like Scheme and do a lot of stuff there. I don't have a particular language that I love. here. So we will be looking at lots of languages here, but we won't be, exclusively trying to look at one programming language. The other course that's often taught is a computational theory course. And this is kind of the theory of computation sort of course. And it usually is broken up in kind of in two parts. One is the theory of programming languages. Once you can how do we write a programming language from a mathematical point of view? How can we prove what we can do and what kind of languages we can create? So there's a whole theory of languages here. And then the other one, once we kind of have that, we can talk about computational theory and talk about what can we prove? What can we prove about what we can compute? Are there problems we can't solve with a normal computer there? Are some problems harder than others? And can we prove mathematically that some problems are harder than others here? And so there's a whole theory of computational complexity from a theory point of view. The theory stuff gets a fair amount into math. And so in some classes, it's not uncommon for this to require a number of math classes before you get to this. Again, we'll be looking at like mathematical proofs and stuff like that. And so you don't have that. So what we're going to have to do is we're going to have to talk and work you through how you structure a proof and how you prove something and some of that language here. So in this class, we're kind of combining those two courses into one course. So we're spending the first 4 weeks talking about the theory of programming languages. And I think this is really cool stuff. What are the theory of programming languages? How can we create generic or, create programming languages? It gets a lot into like compiler theory and how computer languages are actually compiled or understood by the computer. Then we get to spend about 4 weeks deep diving into programming languages. So what are the type systems? What are the different types and why do some languages you have to declare variables and some languages you don't? How do they manage that, sort of stuff? How do we pass parameters? What is the memory system when you declare variables and you call procedures? How does that relate to memory and the stack and that sort of stuff? And some of the more advanced principles of programming languages. And, we'll look at, so basically, we'll spend a whole week looking at different types of loops in the main programming language. So right now I'm looking at mainly Java, JavaScript, and Python as our three languages. We might JavaScript and TypeScript, I guess, together, because again, they're very similar and one is just a little slightly different. So that's right now. And let me know if there's another language you're seeing a lot, but right now I'm thinking Python, Java, and JavaScript/TypeScript are the three main languages we'll be looking. So every time we look at an example, we'll look at examples in those three languages at least here. So again, we'll spend a whole week looking at different types of loops for loops, while loops in all the languages and how they compare, and then talk a little bit about some of these other more obscure languages there. Same with arrays or collections or lists. We'll spend a week looking at that. So that's this analysis of programming languages. Then we spend about 3 weeks on the theory of computation. What can a computer actually compute here? What can we prove and what can't we prove about the theory of computation here? This gets us into what we call Turing machines and P versus NP, non-polynomial time versus polynomial time algorithms and NP-complete issues and stuff like that. And then at the end, you'll do a final research project. And again, you can choose something between something that's more applied to programming languages or more theoretical, depending on, kind of gives you a chance to kind of deep dive into one of these topics here. So, all right, textbooks. So, because this combines two different courses at a normal university, I don't have a good textbook that we can just use all the time. I will be using 4 different textbooks. I have these 4 textbooks that I'll be using to that I've been using to prepare this course and set up the topics for this. But I really don't expect you to use those 4 textbooks. I'll be bringing them and talking about them to you. There is a nice free open source textbook on languages and this sort of stuff. It is older, but again, to tell you the truth, a lot of this hasn't changed that much. The theory of computation, there has not been a lot of changes in the theory of computation in the last 30 years here. And a lot of the stuff on programming languages, there's some new stuff that we'll bring in, like lambda expressions and stuff like that, null safety sort of stuff. But much of the underlying theory of programming languages have not changed that much. I mean, so here's an example. This is my computational theory book from when I was a student here. How old is this thing, you ask? I don't know. It's got my name written in it still, and my room number, so that's good. This is from 1986 here. And again, a lot of this sort of stuff is just what we'll be covering in class here. This is a one of the Zipsters. So this is one of these. This is the 2nd edition of Intro to Theory of Computation course. And again, a lot of this hasn't changed that much since when was the 2nd edition of this put out? This is 2006 here. So again, a lot of these topics haven't changed much in the last 20 years. Now, one of the nice things about that is that means that there's a lot of material out there on this, and it hasn't changed much in the last 20 years, which makes it a good topic for AI models. So I've been working hard to integrate AI into this. Now, we talk a lot about AI in teaching and how we think, a number of us think that a lot of the future of AI is going to be, or teaching is going to be having specific like AI tutors that will know you and help you learn this material. And so I'm going to try to set this up. So we'll be using AI a lot as an assistant to help you teach and explain this stuff and integrate these topics together. So we'll talk about that in a sec. So, okay. Every week we'll have a new unit. Every unit will basically follow the same format here. And this isn't that different from my typical format, so we'll talk about it. So Tuesdays, like today, Tom will lecture, that's me, for up to an hour. Probably more like 30 to 40 minutes is my goal there to cover, basically introduce you to the new material. Then I'll provide a set of AI prompts that'll walk you through this material. So I'll provide you like with 6 to maybe less than a dozen AI prompts that walk you through specific components of that material, and we'll want you to work through that. So we'll work through that. And I think what we'll do in class is we'll let you try the AI prompts and read through them, and then we'll kind of pull some of the AI prompts out and talk about where you might get a little bit confused on Tuesdays there. And you will create a QQTP for this. I don't know if we've used QQTPs much in these recently, but that's a question, a quotation, and a talking point. So you'll go through these points and you will create a question or a quotation, a question, and a talking point. And you will submit that to the discussion area to share with everyone. And then so Thursday, when we'll start class, we will spend up to half an hour going through everyone's questions and talking points and talking about them and see what did you see on Tuesday? What did you understand? What didn't you understand? And going through that. So by every start of class at 10 o'clock on every Thursday, you've got to have your QQTP submitted here. And this goes same for the online students here, that you need to submit the QQTP by start of class on Thursday. Because we'll go through those in class. Then we'll jump into a learning activity. This will often be kind of a POGO worksheet where you'll work through and do some applied or some questions and that sort of stuff. So there'll be kind of a worksheet for you to walk through each time. I would say about half the time it'll be a team or work either in pairs or teams of so either in 2 or 3. Right now I have it in 4s. I really don't like having you work in groups of 4. I think we'll switch it back to 2 or 3s because I think with 4 it's just too many people working together. And again, there'll be options if you're doing this asynchronously to do it asynchronously. So usually on Thursdays, we'll see who shows up in class there. We'll assign those people to whatever pairs or teams of 3, whatever we're doing that week. Sometimes it will be individually there. And then whoever's not here and the online students will assign to asynchronous teams, and you'll do that. So do that learning activity every Thursday. And again, I assume that'll take about 40 minutes to an hour for that. So as far as due dates, the learning activities are due Sunday nights, and of course, you got to have an assignment every week because it's my class. So again, based on this, we'll have a short assignment due every week here also. Each one of these is worth 10 points each. So your QQTP, what we do Thursdays, your POGO activity, and your assignment. The learning activity, in-class learning activity is not actually due till Sunday night because to allow asynchronous people to submit those. And again, I know some people even in class, they like to kind of not have the pressure to turn it in right after class here. And then the assignment will be due every Sunday night also. Yeah, so that's the basic layout. How's that? Does that make sense? Let's jump to the syllabus and see. Right, so like I say, again, we generally meet in class, but again, we have online students as a high flex class. And again, the 2 sections are combined here. So, I mean, you're free to move between high flex, online and in class and vice versa as you need to for this. So you don't have to, I mean, there are 2 different sections, but the sections in Brightspace are combined and everyone's in this kind of together here. So as far as Brightspace is concerned, I'm concerned, it's one big happy class. Again, here's my Zoom link and this is the Zoom link, the class that we broadcast on and that sort of stuff. Again, I have office hours, so you can click on this. I don't know if I've set office hours up for this semester. Yeah. So like you can click on these and schedule a time to meet with me on Zoom. This is particularly effective for online students, but anyone can do that. And I have students who will just meet, with me every Sunday at 7 or something like that. That's fine. You can do that regularly if you want, or if you just are struggling with something or want to talk about something there. I have office hours from 9 to 11 on Wednesday. No one ever comes to my office hours. I just sit in my office and grade there. So you feel free. But tell you the truth, so Tuesdays and Thursdays, I teach 3 classes, 10, noon, and 2. So I'm teaching from 10 o'clock till 4 o'clock there. So I'm basically teaching all day from your point of view. Yeah, I'm free before 10, but students usually don't grab that time. Monday, Wednesday, Friday, though, I don't teach. So I am available a lot. I'll be here basically from 8:30 till 3:30, Monday, Wednesday, Friday. So feel free just to stop by my office, text me, or, and stop up, or I can stop down here. So if you need to track me down, I'm free a lot Monday, Wednesday, Friday. And again, everyone knows, so this is my cell phone number. Feel free to just text me at any time with a question. And again, a lot of you know that, yeah, if you can, even if you want to Zoom at some weird time, you can just text me and do that and say, can we jump on Zoom, or I have a question for this, or just send me something. So that works out fine here. And again, you don't have to worry about texting me. My phone goes silent when I'm sleeping, so you can text me in the middle of the night, and I'll ignore you. Well, my phone will ignore you. I would not ignore you, but my phone will ignore you until I'm awake. So, and again, this kind of talks about the course outcomes is a mix of theory and programming language sort of stuff. Again, all the assessment is the QQTPs, the assignments, the learning activities. Each one of those is worth 10 points here. And then we'll do our final research paper at the end here. So, and this kind of lays out the schedule of what topics we'll be covering when here, if you're interested. So, okay, like I said, I think we've covered most of the stuff in the syllabus here. So let's talk a little bit about what we're doing this week here and how this will work out. So again, there will be the QQTP, which will be actually in the discussion area here, and it's due. Yeah, so you have to have your initial post in by Thursday at 10 a.m. here. We have our learning activity. We'll do this largely in class on Thursday, but it won't be there. So again, this will be a worksheet for us to work through in class. This first week, it's not too hard. It's pretty simple, just to kind of get us into this routine here. And then similar for the assignment, you can work through that. And again, I tried to structure that relatively simple for this first week, just to get you through this stuff. One issue I have is that with Brightspace, I can either set up assignments so you have to submit a file, or you can't submit a file. There's not a file optional one in Brightspace, which seems really strange to me there. So right now for like the learning activity, I'm making that just a text submission because I just want you to submit the link to that document there. But for the assignment, I'm doing a file submission so that you can, do the assignment and submit it as a PDF or something like that there. I am fine with the assignment if you submit a link, again, there's a comment area or something, you can submit the link and just share it that way with me. And, Ryland's graduated, so someone should take over for Ryan's job and always submit me a picture of a cat there, because I really appreciate getting a picture of a cat every week with Ryland's assignment. So if someone else you don't have to do a cat. You can do some other picture. That's fine. I don't want to pigeonhole you into a cat picture, but if you need to submit a file, you can just do that. So again, figure that out. But again, I'm kind of tied because I wanted you to be able to submit a file, but some of you will just submit a link, and that's fine also there. So, okay, let's uh jump into the QQTP here. Well, I'm going to jump into learning resources, and then that'll lead, I think, right to the QQTP here. So, um, again, these are some of the topics we'll be doing, and let me just show you kind of what these textbooks look like. So here's Zister's theory textbook. I think. Maybe. Maybe I won't show you a textbook. There, okay. So, all these textbooks have this kind of introduction chapter, and that's what we're going to be going over this week is this sort of material. Just why do we study this stuff, and um, what are the concepts we're talking about? So again, this intro chapter just talks about this theory and how we've been discussing this since the 1930s, and talks about complexity theory, computational theory, automata theory here, and starts introducing you to some basic math stuff, like what is a set here, and the method they'll use to explain a set and a subset, and walks you through some of this basic language. This is often what would be covered in a discrete math course, for example, here. Talks about some diagramming techniques, often with set theory. Talks about sequences or tuples and how we could define those here. Talks about functions and relations and mappings, and gets us into some of these domains here. Again, so we'll talk a little bit about these, but I will also kind of introduce these as we get to them here. And again, we'll be doing some math here, but we'll try not to. I'll assume that you don't have a big math background, so I'll try to explain the terminology and the topics we'll be using as we go for this. So also talks about what we call graphs. I don't know, directed and undirected graphs. So these are not like bar charts. These are graphs like this that will be kind of like network maps, I will almost say, where we have nodes and we have connections between those nodes for this. So, okay, so that's kind of where we're getting to from this textbook, is just kind of introduce this stuff. So how are you going to do this? We're going to have you look at some AI prompts here. So why don't you go, you can either go to it here, or if you just go to the QQTP link, that will link you to the same document, the Unit 1 prompts.
I think we need access to it.
Oh, you don't have access to it? Oh, it's restricted. Isn't that nice? Okay. Now let's see if that'll work. So the idea is that you take these prompts and, well, you'd make a copy of this document here. So get here, make a copy, go to File, make a copy, make your own copy of this. And again, how you organize your Google folder is up to you, but I would put it into a CIS 477 folder and have you'll have one of these for each unit for that. So think how you want to start organizing this stuff. So you want to select one of the AI models here and work with them. I I don't have a preference for the AI models. I'm just gonna start with ChatGPT, I guess, here. I'll just warn you, because of some research and stuff, I do pay for ChatGPT, so I have access to some different ChatGPT models than you might here. Uh, so I don't know what you see as far as ChatGPT models. That'd be interesting to see what models you can have access to. But again, you go to one of these models here. And again, some of the, well, one, the Gemini model, when I go to this with my CSS account, it says I don't have access to it. So, but if I go into a non-CSS account, I can have access to it. So if you have your personal Gmail account, you can, that's where I use Google Gemini is with my personal Gmail account there. But I don't log in with my personal account on these computers in the lab here. But again, and there's these other ones you can try. So once you're there, we want you to do this prompt. Generally, there'll be a context setting prompt where you kind of set up the AI to tell it what we'll be doing. And again, we want to make sure that we're trying to do this at an undergraduate level. A lot of this stuff is often taught at a graduate level, and so we don't want to do graduate level stuff there. But we also want to make sure that we don't want just a high school or a beginner's level sort of stuff. And we want it to kind of make sure it knows kind of what we're doing. So I just have a general prompt that I give it to kind of set up what we're expecting from this. Okay, and it should say, I'm happy that you're ready to ask me questions. And then you can just take these prompts, put it in here. And it should walk you through this. And I've been going through these. I try to set up prompts. So, and I've been comparing this to what's actually in the textbooks there, because again, we sometimes run into errors. So generally it does pretty good. Again, one of the things is that this hasn't changed a whole lot in the last 20 years there. So there you don't have to worry about, oh, it's talking about Python 3 and we're on Python 4 or something like that, or 4.5, something where it often gets confused with technology stuff. This stuff is pretty straightforward here. There are a number of places where I do see it sometimes making up stuff, particularly sometimes where some places. So I will tend to note on some of the prompts, you should fact check it here or there. And I'd be interested if you think that it is giving you an incorrect answer somewhere, let me know and we can adjust these prompts. But the idea here is that you could just take the response here and paste it in this. I better make a copy of this. I haven't. I don't want to change the original document. So again, you paste one of these prompts in here, you would then put in your response here, read through it and see, maybe there's a follow-up stuff something in here you don't really know. What is programming languages, imperative versus declarative languages here? Object-oriented functional procedural languages, impact on development. So maybe you can, there's something here I don't really understand that. So maybe, you can then create your own follow-up prompt, especially if there's terminology it's using that you don't understand. So you know how to ask AI. Can you tell me more about the finish of each? Now, again, this is set up at the original spot, so it should be providing you examples in Java and Python and JavaScript here when possible. So like here, it is talking about this. And again, because of our initial prompt, it will be tending to show examples in Java and Python here. And in declarative languages, SQL again wasn't one of them, but it's a common example. But it's also showing JavaScript and Python there and talking about that here. So again, the idea is that you can, if there's something you're not understanding, you can then ask the AI right there live. So basically, we're trying to use AI as a textbook. I don't know how this is going to work. This is the first time I've done this in the class. So we'll kind of see how it works. I've been testing it out and I'm pretty happy with it. So we'll see how it works. So again, you can do your prompts there. Then you can go on to the next prompt for this. I'm going to highlight the prompt responses in a color so it's easier for me to keep track of them. You have to see if AI gives you too much stuff or if you want more stuff, right? So you can always ask AI to condense it or do it, give you more examples of that sort of stuff. So you can kind of structure that. I'm going to try to refrain from telling you all about the history of programming languages because I've lived the history of programming languages and I find it very interesting and cool, but I'm guessing you might not find it so cool. I will bring in some history as we go along, but like Pascal, and we'll talk about Pascal there, but I learned Fortran. I learned Fortran in my undergrad year. I used to program a lot. I used to teach Pascal before Java here and C. So, uh, so look at that. Okay, I'm gonna just let you go through. So go through this. Try to get some stuff. And remember, what you want at the end of this document, you want to come up with a question, a quotation, and this can be from AI, and a talking point. So what is a talking point? It's something that you think we should maybe talk about in class or together that you'd like to learn more about there. So it can be anything from, like, I really don't understand the difference between imperative and declarative languages. Is that important for me to know? Or I wish Tom would tell me about some stories about learning Pascal and what Pascal is back in the olden days. So you can any sort of talk, anything you want is a talking point. So that'll be something. Okay, so you want to do those, and then you'll want to go in and put those in our discussion area. Remember, in our discussion area, we'll want them posted there. Here. Okay, I'm going to pause the recording and stuff for a little while here. So before I go, Sim was asking, are we supposed to paste in the code examples or from the text? To tell you, I don't care what you paste in your version of these notes. Again, this is kind of like you creating your own textbook or your own reading material here. So I would just paste in everything here. But again, if you don't want to, if you want to paste in something shorter here or something like that, uh, that's fine. So basically, this is you creating your own version of the textbook. I won't see these prompts and your stuff. If you just even didn't do this, I would not know. I only want to see the QQTP. So again, I'm telling you, you should do this. I'm not requiring you to do this. And how you do it is up to you. Whatever you find is the best way of learning for you here. Okay, now I'm ready to pause this, I think. Okay, I'm going to jump in here again with a couple of pointers of this. Um, so one of my, I think, roles here is to try to tie this together. So like, um, you might be looking at this and you're going, well, why am I even doing this? Because Tom doesn't require me to turn this in. Do I really need to do this? And so what I will try to do is tie in these prompts to your later assignments there. So like this one, here would be like discuss the key factors in program design, uh, like readability, writability, efficiency, that sort of stuff, and provide examples of these trade-offs. So you will hopefully read about that so that when Thursday come and you're working on your worksheet here, one of the questions are, when choosing a programming language for a new project, list 6 factors you should consider when choosing a programming language. And you will say, oh yeah, we looked at readability or efficiency and that sort of stuff, and you can do it. And again, you can ask AI again, but hopefully you'll have some background into that here. And again, sometimes like I want on Thursday, I want to delve into how compilation really works. We often just talk about compiling a program, but it is actually, 10-step process often to come, or I don't know what, 1, 2, 3, 4, 5, 6, 7, an 8-step process generally to compile a program. But in prep with that, I want you to just remind yourself what the difference between compiling and interpreting is. And again, this is something we talk about in CS principles, starting there. What's an interpreter and what's a compiler and how they are different. So I want you to kind of remind yourself what those are so that on Thursday, we can delve into what are some detailed stages and how does compiling actually work here. So that's what I'll try to do is I'll try to, we'll take your prompts and then we'll try to bring them in. So there's actually will be stuff on Thursday that you have to do. And same with the assignment. There will be stuff on the assignment they'll do. This week it's a little harder because again, it's a lot of just intro stuff here. I will warn you, and again, I warned you that sometimes AI won't be the greatest here. When you a lot of this is just introducing stuff that we'll be covering later on in the class. So our prompts are things like illustrate, talk a little bit about the Bacchus-Nauer form, BNF, and how it's used here. Because we'll spend unit 2, next week, we'll spend the whole week doing this BNF form there. So we just want to give you a preview of that. And so it's just a generic prompt, but I'll just tell this generic prompt doesn't, it does a good idea, but my AI here likes to actually show you some BNF, as it's trying to explain things to it and set things up. And these are not the best results. So these are just examples. Next week, we'll actually do this, and I have to provide actually more detailed and better prompts to actually get it to give accurate examples. And we'll often give it a grammar and have it talk about that. But so like here, the idea here is these are production rules. We're creating an if statement, and it is made up of the word if, and then a parenthesis, and then an expression, and then another parenthesis, and then your statement. And then there's an optional section that says else and another statement. And a statement is made up of a block, an expression statement, and an if statement here. This isn't correct. It should be a block, expression statement, and end block here. Maybe, yeah, here. And again, they're defining what a block is here and that sort of stuff. So again, and also their expression is just ... So again, this is not an actual good grammar. This kind of illustrates the idea, but the prompts here are just not set up for that. So next week we'll actually be doing this, and we'll be looking at actual better prompts that'll generate accurate, because these can give us accurate grammars. We just have to give it the right prompts there. So just be aware that some of these sections here, giving you an overview, some of their examples in some of these things are not as good as I'd hoped it would be. So, okay, questions on this? How is this going? You're working through these? Which AIs are you using, can I ask right now? So I use ChatGPT. What are you using as far as AIs? So ChatGPT. Which model with ChatGPT do you have access to?
I have a paid version.
Okay, well, I don't care about you then. Yeah, so if someone using a non-paid version, what are you using with the free version? Claude? Okay, how's that doing? Pretty good. Okay. Anyone using a free version of ChatGPT? Yeah, what model do you have up here? Does it say? Well, okay, that's the one I'm using. So, all right. 4.0 mini, I think. Is that the free version right now? Okay, that's a pretty good model.
I think if you have an account, then you get a slightly better version.
Yeah, I mean, I have 4.0. I can access 4.0, not the mini version, which it does a little better result. I don't think we really, and they have 0.1, which is their reasoning model, and I don't really think we need to have the reasoning model here, but again, you can try. Is anyone using that?
It's like it's good with like more complex problems.
Yeah.
Because it's like it takes more time to like first find and identify the actual
Right.
answer.
Yeah, it's doing multiple prompts and combining the results from multiple prompts. Yeah, together. Yes. So, okay, someone else is using Claude. What else are people? Is anyone using something other than ChatGPT or Claude? Which one? Copilot? Oh, okay. I haven't tried it here. Maybe we'll take that off the list. So, okay. 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 Well, let me know which ones you want. So I think I'm going to stop the recording for the day. Let me see. I think we're done. Again, so yeah. So just by Thursday class, post your QQTP, and we'll talk about that on Thursday for this. Okay. Let's stop.